In this question is concerning about IQR interquartile range. To be honest, I think that A is more difficult than part B because B they fix the value of Y. Only one variable that you have to think about different situation. But however, part A, both X and Y is any number that you can choose. So this is more flexible and more difficult to understand. Don't forget that IQR is the measure of dispersion, which means that if the number are highly concentrated, then we will have the least possible value. If the number are widely spread, then we have the greatest possible value. So therefore, when we talk about the least possible value, the most concentrated situation, maybe we consider most the data are concentrated in group 1. So we can assume this one is 1000 and then Y is equal to a small number, maybe 1. It's obvious that this result dominate the whole distribution. If we use a bar to show it, very little thing are 0, and then a huge part is 1, a small part is 2, and a small part is 3. So Q1 and Q3 are the same, 1 minus 1. Therefore, the least possible value of IQR is 1 minus 1, we get 0. Or you may assume that Y is a huge number compared with X. You will get the same result. 2 minus 2 is give you 0. Now, for the largest possible values, we have to think a situation that most of the value are the extreme number. So comparatively, X and Y should be really small. And X and Y are limited as positive number. So we just simply let X equal to 1 while Y equal to 1 also. If we use a bar to present it, in this case, 9 is talking about 0. 9 of them is 0. And then we have really small part, which is 1, really small part is 2, and then most of them is 3, which is talking about 13 values are 3. So in this case, obviously Q1 will be 0, and Q3 will be equal to 3. Remember, IQR is not talking about the difference of frequency. It's talking about the difference of the response of Q3 and Q1. So therefore, greatest possible value of IQR is equal to the Q3 minus Q1. We get 3 minus 0 in this situation, and which is 3. That's the maximum difference in quartile already. Finally, part B, they're talking about another situation that Y is fixed to be 3, and then while X is still keep changing, it's given that the median of distribution is 2, so you will use the bar to present the idea. One of the extreme case is the first 2 is the median. If this one is the first 2 here, that means we have 9 together with X numbers. In left hand side, there are 9 plus X values in left hand side, and then we just count the first 2 here. We still have 2 more. The result is 2, so we have 2 values together with another 13 values. So we know that 9 plus X should equal to 2 plus 13. This is considering the maximum number of X, maximum value of X. In this case, we find the maximum X here. It is 15 minus 9, so the maximum value of X is 6. Similar reason, if we consider the minimum X, another extreme case is the median is not the first 2, but the last 2 here. So we have 2 here. Because it's already the last 2, right hand side we have 13 values. And then left hand side we count 1 of the 2, so we have 2 values here, we have X values, and we have 9 values here. So this is 9 together with X together with 2, number 2. So there are these amounts of values. So for the minimum X cases, we just write down 9 together with X together with 2. Left hand side should equal to right hand side number of values, 13. So X is equal to 13 minus 11, which is 2. And then we can answer the question now. The question asks how many possible value of x here, while x is positive integers. Therefore, x can be 2, can be 3, can be 4, can be 5, until 6 here. So they ask us how many possible values, then our answer is 5 possible values.